Okay, so I'm Dr. Ganesh Gollavelli, Associate Professor from Aditya Engineering College, Jawaharlal Technological University, Kakinada, India. Well, today I'm going to discuss about smart graphene for portable water technology.
Sorry to interrupt you, Dr. Ganesh. We cannot hear you.
Okay, so how about now? Can you hear me now? Today I would like to present smart graphene for portable water technology. Can you hear me now?
Yeah, we can hear you. Yes, yes. So clear. Thank you.
Okay, then thank you.
Yeah,
Great. Wow. So this is the title of my talk, and so here are my outlines. Today I would like to discuss about graphene, how to synthesize a graphene, and challenges in graphene synthesis and water purification technology. And since so smart magnetic graphene, its characterization, followed by its applications for heavy metal removal like chromium-6, arsenic-5, and lead to toxicants in water, and followed by antibacterial activity or disinfection, biocompatibility, and its conclusions. Wow. So here is the introduction about carbon nanomaterials. As we know, so carbon materials are classified as zero-dimensional fluorines, one-dimensional carbon nanotubes, and two-dimensional graphene and three-dimensional graphite. So here I'm interested to talk about two-dimensional laid material that's called as graphene. I hope some of you know, but maybe if nobody, so let me give a brief introduction about it. So this is the graphene. This is the thinnest material in the universe, and it's a flat monolayer of hexagonally arranged sp2 carbon atoms tightly packed into a two-dimensional structure. It's a basic building block for all graphitic materials such as fluorines, carbon nanotubes, carbon dots, and carbon nanodiamonds, etc. It has unique optical and electrical properties. As a result, it got a Nobel Prize in 2010, and it also have high surface area and biocompatibility. Wow, so here is the graphene chemistry. So if you go for the graphene, it could exist a graphene, graphene oxide, and reduced graphene oxide. Can you see my presentation? Wow. So here, if you can consider the graphene.
Sorry to interrupt you, Dr. Ganesh. Please reshare your presentation.
Okay.
Hello, what's wrong?
So how is it okay now?
Yeah, it's right here. Just carry on, please. I can't see the slide.
Yeah, just Doctor, scroll your slides because sometimes it looks your slides stuck there.
Yeah,
Just try to the next slide.
Okay.
Okay, that's good. That's okay.
Is it okay now?
Okay. Talk, please.
Yeah.
Can I continue?
Yeah. Talk, please. Start talking about your slide.
Okay, so you could be able to see my slides. So they're visible. Hello, can I continue?
Yes, doctor, your slide is visible. Just try to move to next slide. Either your slide can move to next slide or not.
Yeah,
I
of
can
course.
see
Yeah,
it.
it could. Yes, it can.
Talk, please.
But here looks stuck because we can only see graphene chemistry slide.
Yeah, that's what I'm going to present. I'm going to present graphene chemistry slide. Yes.
Yeah.
Okay.
Let's talk about it.
Well, so when you come for the graphene chemistry, it has a pi electrons as well as oxygen functional groups. As it has a pi electrons, so we can go for a physical option of many molecules on top of it. Like, so you can physically mobilize iron oxide nanomolecules, polymers, or oligonucleotides, or any therapeutic agents like pi-pi interactions. At the same time, we can also go for covalent interactions with the pi bonds and oxygen functional groups. See here, we have conjugated double bonds so that we can go for cyclohexane reactions, and here at acid function or oxygen functional groups, you can also go for substitution or elimination reactions. So here are the applications of a graphene. Mostly it is useful for electronics and atomic sensors and biocompatible materials, as well as we can also use in water treatment technologies. Wow. So when come for the graphene synthesis, mostly just we adopt two methods. One is a top-down method, another is bottom-up approaches. In top-down method, we have microwave methods, liquid phase exfoliation, and mechanical peeling. Whereas when you come for the bottom-up approaches, we have chemical synthesis and chemical vapor deposition in order to get a a sheet-like graphene structure. But here, just I have adopted a microwave method because it has it will take less time. It's a green energy source. Mostly, it's an economic. Whereas I do not follow other methods
Sorry
because
to interrupt you, Dr.
Yeah.
Ganesh, your slides are not moving.
I could able to move from my side because I have. Is it okay?
Please don't put your slides on slideshow mode, so we can see the changed slides.
Okay. Is it okay now?
Yes, please continue.
Okay, thanks. Wow. So other methods, the disadvantages of other methods, along with the advantages are that it is a time and energy intensive, and it needs toxic chemicals, and it's somehow expensive. But whereas microwave method, it's green technology. You can say it needs green energy. It's somehow economic. It's not very sophisticated, and even you can prepare the graphene within a less time. As a result, so I would like to prepare the magnetic graphene by using microwave technology. And thing is that as I would like to adopt the smart magnetic graphene for water purification technologies, usually we have three kind of methods to purify the water. There's chemical methods, physical methods, and biological methods. So here I would like to just go for an absorption method that comes under physical methods of purification of drinking water. So here just I prepared a smart magnetic graphene through micro approach. I would like to go for a magnetic separation instead of regular filtration methods. Wow. So here are the challenges I would like to discuss. One is the synthesis of graphene, another is drinking water, safe drinking water technologies. So when it comes for the graphene synthesis, usually it will take longer reaction times. It needs toxic reducing agents, and it needs high temperature, skill, and investment. So now I would like to just overcome these hurdles by using microwave technology, what I'm going to present. Another problems in safe drinking water is that, so Dr. Fulka has already presented. Well, so it has some problems that it contains heavy metals, organic pollutants, and bacteria, virus, or fungus, whatsoever. And also, if you need any adsorbent, we have to address the biocompatibility issues. So there are a lot of literature, but people usually address only individual problems, not all together. But here in this work, just I try to just summarize all these problems with a magnetic graphene. Well, so here, this is the work I'm going to present that I was published in Sustainable Chemistry and Engineering. That is a facile synthesis of smart magnetic graphene for.
Sorry, Dr. Ganesh, still your slides are not moving. Is it okay if we will share your slides?
Yeah, okay, yeah, no problem. You can share.
Okay.
Wow. So can I continue?
Is this your current slide, or you want to move to the next slide?
Means where you hang on, means where the slides are not stop moving.
Just say the slide. Is it okay?
Yeah, maybe you can go to the previous slide. Yeah. Maybe from here I can continue.
Yes. Please mention as next slide when you wanted to change the slide.
Okay, sure. Yeah. Well, so this is the work I'm going to present today. Like facile synthesis of smart magnetic graphene for safe drinking water, like heavy metal removal and killing bacteria, so-called disinfection control. So here we prepared a graphene oxide, and we made it magnetic. And the optimum material called a smart magnetic graphene because it could able to kill the bacteria, it's biocompatible, and also it could able to remove many heavy metals. Next slide, please. Yeah, so this is the schematic synthesis of smart magnetic graphene for drinking water applications. So we have prepared a smart magnetic graphene from graphite. So at the beginning, we have taken a graphite through Hammond's oxidation method, we prepared a graphene oxide. Here, graphene oxide or graphene is called as a single layer of a graphite. So because of oxidation, so the graphene, the graphite surface would get oxidized, and these layers would be separated out. Wow. So now from the graphene oxide, we intended to prepare smart magnetic graphene. In order to make the graphene oxide into graphene or graphene oxide into magnetic, we had to reduce it. In order to prepare reduced graphene oxide, we need to reduce the graphene oxide into reduced graphene oxide. And in order to make it to magnetic, we have to add some iron precursor. So these two things we can achieve in a single step approach. That is, we have taken a graphene oxide, added ferrocene as an iron precursor. Together, just we kept in a microwave oven. Just within a minute, we got smart magnetic graphene. Means the graphene oxide has been reduced. We have well restored structure. Biochemical structure. On top of that, iron nanoparticles from ferrocene has been decomposed and decorated on top of it. And finally, these smart magnetic graphene has been used for removal of various metals like chromium, arsenic, and lead, silver, and mercury, which are called as poisonous metals according to WHO and USPA. And after that, if the water may contain bacteria, here E. coli is the most water contaminant. So as a result, we have chosen E. coli just to demonstrate the antibacterial activity. So finally, so in order to demonstrate any adsorbent, that should be biocompatible. So in order to study the biocompatibility issues, we have taken zebrafish as an aquatic model, because zebrafish, whose genomic structure is almost close to the mice as well as the human. That's why we have taken the zebrafish as an animal model to demonstrate that smart magnetic graphene is biocompatible. So overall, so the synthesis process is green because we use a microwave technique, and the preparation time is just 1 minute. As a result, we can reduce the solvents and time and even energy and etc. As microwave energy is called as a green energy source, so we can say that this is the green synthesis of smart magnetic graphene from graphene oxide. Next slide, please. Wow. So once we prepare the material here, we went for the characterization from atomic microscope, TEM, and squid analysis to know its magnetic property. Because in order to go for magnetic separation, the material must have high surface area as well as a magnetic property. Wow. So here, figure A represents the atomic force microscope of graphene oxide, whose height is 3.07 nanometer. It means it's mostly 1 or 2 layers in thickness. Once we add a ferrocene and go for microwave interaction, we can say that the ferrocene has been decomposed on top of the graphene oxide. So if you go for high resolution in the TEM, you can see that the iron nanoparticle has been embedded inside the graphene system. Means mostly they're like covalent interactions. As the iron nanoparticle has been covered with the graphene layers, it will it will not prone to the oxidation. Mostly iron will go for oxidation, but as it has been protected with the graphene layers, we can avoid its oxidation under absorption conditions. And finally, we check that the graphene oxide has a magnetic property, where you can see that this is the dispersive smart magnetic graphene. And under magnetic field, about magnet, you can see that all the dispersion has been came to one end. And from the squid analysis, we can see that it has very good magnetic property. It's like super paramagnetic material, you can see. Here, these are the ratios of graphene as well as ferrocene. At high ratio of graphene oxide and ferrocene, you can see that there is a highest magnetic property. Next slide, please. Wow. So once we prepare the material, so our aim is to go for absorption of heavy metals and killing the bacteria and biocompatibility. The first one is that we have taken smart magnetic graphene. This is the black dispersion you can see here in the image, and it is a magnetic because if you keep a magnet nearby to it, so it will get separated from the solution. Wow. So we have taken smart magnetic graphene solution. To that we added heavy metals. The heavy metals would get absorbed on top of smart magnetic graphene. So here the orange spheres represent the heavy metals like chromium, arsenic, and lead. These heavy metals get absorbed or physiabsorbed on top of the smart magnetic graphene at these adsorption parameters. Like we have taken SMG at 5 milligram per ml, and adsorbate should be like heavy metal should be from 0 to 5 ppm, and pH maintained at 6.5. The interaction time is 2 hours, the shaking speed of 300 rpm, and the temperature is 30 degrees centigrade.
Sorry, Ganesh.
Yes, madam.
It's
Yeah.
up to you. Just
Yeah.
you know, just we have time for next one, next speaker.
Okay, just yeah, 3 minutes. Within 3 minutes, I can finish now. Yeah.
So it's 2 minutes is okay.
Yeah. Yeah. Yeah.
Please.
I can. Yes.
Finish, please.
So yeah, after absorption, just went for ICP-MS analysis to see that whether the removal efficiency of heavy metals on top of smart magnetic graphene. Next slide, please. Well, so here effect of absorption parameters, like with the concentration of heavy metals, you can see that. Yes, madam. Yeah.
Thank you. Thank you. Are you finished?
No, just 2 minutes. Just give me 2 minutes.
It's okay.
Okay, so here these are the absorption parameters. So with increase the concentration, the flow means the absorption has been increased. Next one, please. Next one, please. Well, so here in a real-time analysis and recyclability slides, here even in real time we got 100% efficiency, and the recyclability, the efficiency has been declined. Next slide, please. Next slide, please. Well, see here, there is an antibacterial activity. You can see that with the time and concentration, the bacteria has been almost dead within 1 hour. Even this also gives the same results. This is a live bacteria, this is a dead bacteria. Next slide, please. Well, so these are biocompatibility issues. Like, when you inject smart magnetic graphene to the zebrafish, mostly they are healthy. Okay, so there is no any abnormality, something like this. So we can say that smart magnetic graphene is less toxic to the aquatic environment or even humans, such how it's a biocompatible. Next one, please. Well, here are the conclusions. We use microacid green and green approach to prepare smart magnetic graphene within a minute, and we can remove heavy metals down to 1 ppb level. The efficiency is 99%, and we can use it for real time, and it has a recycling efficacy too. It has high antibacterial activity, non-toxic to zebrafish. It means it's a biocompatible. So it could be an ideal adjuvant for water purification technologies. Wow. So thank you. So thank you for your